All right, so 6.2 is ionic compounds. An ionic compound is a type of compound that exists when a transfer of electrons has occurred between two ionically bonded species. They usually are composed of a metal and a nonmetal. The metal willingly donates one or more electrons to the nonmetal. And you can see in the picture here, we have sodium metal reacting with chlorine gas. And sodium metal does look like that. It's a very soft metal. It's almost like butter. You can cut it with a butter knife, literally. It might look white when you get it, but when you cut through, the inside, it's going to look super duper shiny, like a metal, and it'll quickly oxidize and look dull again. But the moment you cut it, it looks super shiny. Chlorine is a greenish yellow gas. Chlorine actually means green in the Greek or Latin that it comes from. But we have a toxic green gas that, it would kill you if you breathed it in. We have sodium metal, which is a metal that is explosive with water. Therefore, you couldn't ingest that. Can't inhale chlorine. When they combine together, they violently react to make table salt, sodium chloride. And so you can see that here. We go from a metal solid and a green gas to a white crystal. That we actually need in order to live. So you can't just base the properties of compounds on their elements. That's not what you do. But you can see there's a crystal structure here for table salt under a microscope. You can see that. And anyways, this sodium chloride has this repeated lattice structure of the sodium ions and the chloride ions. The chlorides are in green, the sodiums are in purple there, and it's just repeating one sodium for every one chlorine. A chemical formula is a representation of the number of atoms of each type of element present in a compound. So for example, we could write sodium chloride. It has one sodium atom for every one chlorine atom. That's pretty straightforward. But what if we had water, H2O? Has two hydrogen atoms for every one oxygen atom. Okay? And this could go on and so on and so forth. There's like millions upon millions of different examples of compounds. I'll just give one more though. C6H12O6. This is glucose, the simplest sugar that there is. This has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Here's some more examples of chemical formulas. You can see with magnesium that needs to lose 2 electrons, it can react with 2 chlorine atoms, each that need to gain 1. And so 1 electron goes to that chlorine, the other electron goes to the bottom chlorine, and you get an Mg2 plus 2 Cl minuses, giving you a chemical formula of MgCl2. Now with sodium and sulfide, you have the metal giving up 1 electron in each of these cases. Here, kind of the opposite of the magnesium chloride. And so you have 2 sodium ions forming plus a sulfide 2 minus ion because it has gained 2. And so the formula for that compound, sodium sulfide, is Na2S. Now you can predict the chemical formula for any ionic species if you remember what the charge of that ion should be based on the table in one of the previous slides. So for example, if I give you, let me move that around. If I give you the elements calcium reacting with phosphorus, which would make calcium phosphide. You look at the table, you find calcium always has a 2+ charge, phosphorus always has a 3- charge. All you need to do is take those numbers and crisscross them. Let me do it this way. Make this one blue. And so what you get as a result is going to be calcium with 3 there, because there's going to be 3 calciums, and a phosphorus with a 2 after it. 2 phosphorus atoms, 3 calcium atoms. Because 3 times 2 positives plus 2, here, let me fix this again. Let me write 3 in red times 2 positive, which I'll say is plus 2, plus 2 in blue times a 3 negative can be a -3 mathematically. What does that equal? We get +6 plus -6, because 3 times +2 is +6, and 2 times -3 is -6. So we have that becoming 6. Those there, a positive and a minus, become minus, and you get 0. It's neutral. So essentially you're finding the least common multiple of everything, but we call this the crisscross method. You just take the charges and you put it to the other species, and that'll always give you the chemical formula. One thing to be wary of, though, is if I give you, let's say, calcium and sulfur. Calcium's a 2+, sulfur's a 2-. If you use the crisscross method, you would get calcium 2 and sulfur 2, but that's not correct, because you can just kind of look at everything as is in the beginning and notice that 2+ is going to cancel out that 2-. So in reality it's just CAS, not that.